Okay, so let's go ahead and get going on our review of what we did on Thursday. My apologies, the cloud recording did not work, so I'm doing this as a second recording using my own system. We'll try to fix that problem in the future. But we're doing two things today. We're doing our conceptual design review, and we're doing our AutoCAD machining drawings from existing solids. So let's start with the conceptual design review. There's as with any good project, there's a project definition. This is the Flip Assist Massage Table. So I am a massage therapist. I belong to a group of massage therapists. I've done probably between 15 and 20,000 professional massages in the last 20, 25 years. And one of the things that always is an issue is when I'm working on somebody who does have an injury and I want them to roll over from prone, face down, to supine, face up. That can put a strain on either the neck, the back, the hips, or the legs. And if any of those are injured, that's not a great thing to do. So we want some sort of a flip assist to help us do that. And I've been interested in this a long time. And I've finally found a device that really does this well. Of course, this is a very expensive device. It's well tested. It's well developed. But it's pretty fancy. So let's take a look at that. I've got it open somewhere here. Hold on a sec, so we can see that video.
For carers and care professionals, there is now a clear answer to one of today's major care challenges: handling service users in bed. The Vendlet V5S is the world's only powered turning and repositioning system. It's the answer to the issues around tissue viability, comfort, and care injury that commonly occur, and it allows single-handed care. As resources and demand become increasingly stretched, the versatility of the Vendlet V5S marks a real turning point in how easily care can be provided to people with limited or no physical resources of their own.
That's awesome.
The Vendlet system fits neatly on top of a standard care or nursing bed. It's simple to use and can be operated by one person. The normal functions of the bed are not affected. It has two color-coordinated electric roller bars, a fully washable turn sheet, an integral slide sheet, and a hand control which is configured to operate each side. The whole turning procedure is safe, dignified, and comfortable for the service user. Here's how it works. To turn the person, you simply raise the sidebars by pressing the two buttons on the hand control. Once in place, you can start the turning procedure while preparing the service user's own position ready for turning. Personal hygiene procedures are easier for the carer too, as one side of the Vendlet V5S.
So, positioner bars, they go up, they roll the person, and they get them to turn over. Now, we're not going to use a powered system. I've been caught on powered systems, and that's one of the reasons why this particular device is so expensive. They've got tons of safety devices. It's super, it's been approved by EU, UL, FM, Canada, Australia, everywhere in the world. And so there's tons and tons of approvals to ensure that this thing is safe. But I want you to notice that there's some sort of a mechanical attachment to the existing bed. That's called an adapter. There's something that positions these things, moves it up and down. Those were on some slides, some linear bearings with some power. And then there's something that rolls these things, makes it go. And so we're going to do something sort of kind of like that. So let's take a look and see. Okay, and so the reason elder care specialists, medical care specialists, they've got these things. They're very, very expensive, but those care providers are getting a lot of money too. And so if you can save one or two of them, it pays off. Not so much for a massage therapist. But we have similar requirements. Okay, we often find our clients that need some sort of therapeutic massage. They need to be turned, they need to be positioned, and it needs to be done without strain, neck, back, hips, or legs. Okay, and so what are we going to do? Okay, we're going to take this concept model here and use the same operational concepts as that Vendlet, but without power and control systems. I have been caught on slow-moving powered equipment, almost lost an arm. I got the thing stopped before I went through a pinch point. I'm not really hip on powered systems if a manual system can do it. It's also much less expensive to use a manual system usually. So that's our goal. We want to do something. And you can see here that there's some sort of a positioning module. Okay, there's a mounting adapter, a positioning module. There's some sort of a roller assembly with a crank. And then there's a roller sheet. And this person will get flipped over. Now, in my thought, we probably need one on each side, one driving and one being driven or following, just to keep the sheets straight. But sheets will roll up on these. There's a roller sheet. And we'll have to figure out how high this goes to actually perform the job. You can imagine if it's just flat down here, the person's going to just slide over. You're also going to need to know that this kind of has to stay out of the way. When somebody's doing a massage, they need to reach the neck, the back, the hips, the legs, the feet, the arms, the hands. And when they roll over, they need to get, the neck, the shoulder, the arms, maybe the stomach, the hips, the legs, the feet, the hands. And so this stuff has got to be out of the way. And we get up pretty close to these. So that's something to think about as you go. Okay, but there's basically going to be three portions or three subassemblies. A mounting adapter, because there's tons of different types of massage tables. Okay, and so this stuff can all be the same, the positioning tube and the rollers, but something has to be able to adapt that to the different types of legs that we need to mount to. Okay? Because, we're not making a whole massage table. We're adapting to an existing massage table. Okay, and then there will be all sorts of other interesting things. It's intended to be inexpensive. These are the things that when you do your design review, you're going to have to account for. Is the design that you've come up with inexpensive? Now, that's going to be in relation to what others have done. Okay, I can tell you about how much money I make and how many years it would take to pay it off if it was a certain price. But we're going to mostly go based on a comparison to your colleagues in the class. Okay? Is it manually operated? How do you operate it? This one just shows a handle and a crank. Maybe that works. Maybe it doesn't. Maybe it needs a gearbox. I'm going to guarantee you it will. Okay? And this needs to be a removable accessory. So those three things are part of it. And of course, it has to be functional and all that kind of stuff. This allows us to do design with a number of different things that are required. One is fasteners, cam locks, things like that. Another is gearboxes. And another is lifting, positioning equipment, hydraulics or pneumatics and things like that. Okay, so my group, DJ Keisu Seifu Kujitsu, has looked this over. I've got 5 or 6 colleagues that are part of this group that all do this professionally. They're all professional massage therapists, as I am. And they've looked this over and said, yeah, that would really be cool. And they would like to see a set of details that are ready for prototype development. If one of you comes up with a good package that we can prototype and develop, we'll do it. Okay? You're going to give it to these people, and we're all going to look it over. Okay? And so the purpose of our project in class is to create a complete prototype documentation package suitable for manufacturing. Okay? And so when you do something like that, you know there's going to be changes. You know certain things will be not working quite right, but your documentation package has to be ready so that somebody can build that prototype. So let's see what the project requirements are. It's a complete product book. That's essentially your portfolio in one single PDF document. So every product has something the equivalent of a product book. It has marketing materials, sales materials, costing materials, production materials, drawings, design reviews, approvals. Everything's all in one place. We call it a product book. And back before we had really sophisticated file sharing systems, it was a book or a set of books that were in the engineering office and copies here and there. And anybody could really dig into that product. Okay? Our product book is not going to be super full. It's going to carry a lot of things, but there will be detailed design drawings of all manufactured components, and they're going to meet common industry standards. For things that are purchased, we can use specifications or tabulated drawings. So it'll hold all of those. Those are things like bearings and fasteners and lubricants and O-rings and maybe even hydraulic gas shocks or pistons and things like that, gears. Assembly and subassembly drawings to help us organize the design. When we look at the design, we see there's 3 parts to it. This mounting adapter assembly will probably be different for every single style of massage table. And so that'll be one thing. And then this positioner and the roller will also probably be a little different depending on the length that it has to cover and how high it has to go up and down. So modules allow us to make each of those separately and then pull them together for the right product. Okay, so it's just an organizational tool within your engineering organization. So assemblies and subassembly drawings that help us organize the design. Our assembly instructions are going to be exploded view drawings. Okay, like an IKEA drawing or a Lego drawing, and that's all the farther we're going to go. Okay, we can get far more into it, but we only have a few weeks. So we can, we've got 6 weeks, 7 weeks. So we're going to do good basic work to show that we can do this. Then you've got your production control drawings. Those are the documents. Those help people make it. They control the production. Bills of materials, lists of materials that help you figure out what you need to purchase in order to assemble or make parts. Purchase orders, where are you going to get it from? How many do you have to order? How long does it take? What does it cost? What inspection is required? That's all information that goes on a purchase order. Work orders tell the people what to build, how to build it. Put this piece of channel on the mill and drill holes, tap holes, make reliefs, things like that, or grab a bunch of parts and assemble them. That goes in a work order. And then the assembly instructions themselves, and those will essentially be exploded view drawings again. And then the most important part is for us is that we have these design review documents also that says you've gone through your design process properly so that this prototype is likely to work. Assembly and tolerances. Every time you're going to put 2 pieces of material or equipment or two parts together, you have to ensure 100% that they are going to fit properly the way you intend it as the designer or the engineer. We use tolerances to do that. So you have to review the tolerances of every part that meets another part and make sure, no matter what, if that part is made to print, it's going to go together. Design strength. You can imagine that this might take a lot of force as we crank that roller, and we wouldn't want things to bend and fall on this person. In all the years I've been doing massage, I've had my table break once. It was pretty bad. It was a guy who weighed a little bit over 300 pounds, and I had to give a whole bunch of free massages because he hurt himself. So we don't want this to break and fall down. We want it to work, and we've got limits to do that. And we'll do some of that design strength analysis that will be based with finite element analysis in Inventor. Of course, cost, because that's part of the deal. It's got to be inexpensive. Manufacturing methods. Now, we don't tell a person how they need to build it. They just tell us their quote and how they're going to do it. But we do have to make sure that we can conceive of some manufacturing method that can be done. Milling, turning, plasma cutting, saw cutting, welding, gluing, depending on what material it's made out of. So manufacturing methods are going to be important. And then maintainability and ease of use. Okay, from ease of use, I learned in the field when I was working with stuff that was going into nuclear reactors and things like that with guys in big suits and big gloves that if you drop a wrench or drop a tool, it's brutal to go find it again. And if you have a whole pack of them that you have to choose from, it's even worse. Ease of use indicates maybe wrenches or one wrench or one tool or even no tools to get all of the mounting and the job done. And the maintainability is, something will go wrong, something will break or jam or whatever, and it has to be easily maintainable or it's not a viable long-term project. And then the end, after you've done your product book, you will create a client design poster that will identify how well yours does the job and try to convince one of my massage colleagues, all of my massage colleagues, that your design is the one that they choose for prototype. So that's what we're going to do in our project. Let me show you now what your job is. I'm going to minimize that and find my SketchUp. So your job is to take the file I gave you. It's got a couple of massage tables and do a very, very basic concept design to show that you understand how this project is organized. So here I've got it, and I've made scenes. I think that's a good way to do it. And I'm showing there's some sort of mounting adapter. It needs 4 of them. I've only showed 2. Must be able to mount to many styles of table feet. So I'm calling that out right now of what I need to be able to do with that. And I'm just showing this. It's going to be some sort of a block. I don't know. That's what we're going to work on next week. Next week, we're going to actually do more conceptual work. I'm going to give you some design principles to go by. And you're going to create your design drawings and bills of materials and things like that for it. Okay, for sure you're going to get the design drawings done. So you should have something that kind of zooms in on this and tells me a little bit about it. And then you go to here's my positioner. I've got sort of a tube going up and down inside of a tube. I don't know how I'm going to power that. Maybe I'll lift it by hand. Maybe I'll have a gas shock lifter. Maybe it'll be a piston. Maybe it'll be a little gear. that I'll use, a rack and pinion gear to make it go up and down. I haven't figured that out yet. I just know there's a thing called the positioner subassembly, and it raises the roller into position and lowers it so that your massage therapist can meet the client. And it mounts to the adapter once the adapter is in place. Okay, and I need 4 of these. And I notice in my design, I don't have anything capturing this roller. I just show that there's going to be, something's going to sit into that thing that will be the roller. I haven't shown really too much there, but I made a note of it. And then the final one for me is the roller assembly. I need 2 of them, 1 on each side. Has to have some sort of gearbox. I don't think I can crank that by hand. I think it needs a gearbox. And so I'll have some sort of crank to make this thing go around, and I need some way to secure the sheet. And when we get to that, we'll talk about that type of design also. Okay, so there we go. That's your job. You make a SketchUp file, and you're going to submit the SketchUp file. Okay, so there we go. That is your review. So you can certify, if you've watched this, you can certify that you've reviewed this and you have a basic understanding of what the project is. And then you can go into SketchUp. I do want it to be SketchUp, just for a very, very brief, quick visualization, and make something akin to what I've done here and what I just showed you there. Make 3 things, make them clearly identified that you have an adapter, a positioning system, and a roller system. Okay, and submit that. So that's the first part of what we're doing this week in this, what we did Thursday. And now we've got these machine drawings from existing solids. And when you click that, it goes to here, and there's just a file with 3 of these, and you want to get 3 drawings done. These are AutoCAD. I give you the solid shape, so you just need to do the drawing. So download the solid shape and get going on the drawing. So that's going to look like this. I'm going to show you how to do that. And I gave you 2 ways. You can use the exemplar way that I teach in Design 301 and 302, or you can use a template that I gave you that includes all of the dim styles, layers, layouts, things like that that you're likely to need. So I'm going to go to New, and I'm going to browse for that template, and I think I downloaded it. So I'm going to go look in my downloads. Yep, there it is. So I'm going to open a new file from that mechanical template. So I just have a new file sitting there. And I can insert, import whatever I want with that other drawing. Okay, so I should be able to insert that block into here. Okay, now I'm going to do it a little bit different way so that you can insert your other drawing into this drawing and be ready to go. But I'm going to show you another way using the Design Center so that you can see how that works too. Okay, so I'm also going to open that drawing that I downloaded. I think it's in here. There it is, Solid Shape 3. So I'm going to open that drawing. And now I have 2 open drawings. I have a drawing that contains all the stuff I need, and I've got this new drawing that is opening up slowly but surely. It's taking its time to open up. There it is right there. Okay, so I can go into the model or whatever I want. And I'll ignore those. So if you remember, I can go to the Design Center, DC, enter, open drawings, and I'm going to pull this over to the side, and I can get stuff from here. Okay, so I can get stuff from here. The main thing I want are dim styles. So if I'm in my solid shape drawing, and I can just pull all the dim styles from my template into here. I can pull all my layers in, so that's how quick it goes. And I can choose the layout, and the layout says a mechanical B. So I'm going to bring in a mechanical B, and now I've got a B size. Okay, and I might need the text sizes, text styles, I'm not sure. So I've got all those ready now. Now for my blocks, remember that when you do one of these, you put the revision title up in the corner, and you put the revision items underneath it. This is just setting up a good drawing. You put your general notes in. Oh, that's got a problem with it. My general notes block has a problem. Sorry with that. You're going to have to explode those. My apologies. You can fix it in yours. There we go. Okay. And then I'm ready to go. I can also put in, if I wanted to, it doesn't show it in that drawing, I can put in my bill of materials and the parts of the bill of materials. But that's not required on this drawing. Okay, so now, how do I get my drawing to start coming in here? I'm going to close my design center now. I go to the layout. This is all review, I hope. Base from the model. It'll take a little while. And there it goes. And I put my views in. I think kind of goes there, enter, and then I can put my other views in there. I'm not sure if that one is in there. I don't think it is, but I'll put it in there anyway. I don't think that view is in there. But there is a view that's looking straight at this. And for that, you use section. Enter. And you can bring it right over here. Enter. And you can move this. And you can move these edges to get a little bit more. See how you can get it to catch the whole thing. There we go. Got it. And you can move this a little bit too. This is a little too big, so I'm going to double click it and change the height. Here's my height over here. I'll go to 0.125. Close the editor. Let me move it first so I can see it. Get it over here. The other way I usually do it is I do it through the properties and change the height. It's easier for me. Oh, my numlocks are not on. There we go. And then you're ready to go. Remember then that when you do your annotations, instead of use current, pick which one you want to use. Pick the dim style to match whatever it is that you're trying to do and put them on. I know there's some XX nuns. And be sure that you're actually catching. See, oh, look at that. Isn't that weird? It says non-associative. Let's check and see what's going on there. Right-click, options. This happens every now and then. It's under user. Oh, that box should be checked. Associative dimensioning. Always want to have associative dimensioning going on. So now it actually gets the part instead of the piece of paper. And I think down here, I think this thing gets a thing like that, and this thing gets a radius. So on and so forth. Okay, so that's how you do these. You get the model and you create the drawing to look like what I've presented. Here's a multiliter, I think, that comes in here. And it says something like serial number ID goes, it should be all caps, goes here. Something like that. It says something like that. And that's okay if that's there. There we go. That's how you do your solids. There we go. That's what we covered on Thursday. And now it's just get down and do the best you can to get that work done.